Dear fellow coders, welcome to One Little Coder. In this video, we are going to learn about doing topic modeling, one of the important topics in NLP, using a library called BERTopic. BERTopic is a library, Python library, that leverages transformers and c-TF-IDF, class-based TF-IDF, to do topic modeling. And what we are going to do in this video is, you will be able to use Kaggle data, so the metadata that is available within Kaggle, and then do topic modeling for the notebooks that are created in 2021. So basically this is like a yearly summary of Kaggle notebooks for 2021, and then we are just going to use topic model to create something that looks like this. So what you would have at the end of this video is, you can just hover on these things and then understand, okay, so there is a topic number 60 that had Titanic and some other things. So there is a topic that is 28 that had reviews, sentiment analysis, and so on. And there is probably, let's say, a topic that had topic number 76, it's about AutoML, H2O, ML jar. So this will help you understand what kind of topics on which people actually created, data scientists actually created notebooks and Kaggle. So there is a very less chance that you don't know what is a Kaggle. So if you do not know what is Kaggle is a platform where machine learning competitions happen, data science notebooks are created, data sets are available, and data science machine learning related discussions happen. And there are a lot more things about Kaggle that you can explore. So what we are trying to do is, we are trying to leverage the data that is available on Kaggle, not a data set, but actually the notebooks that people create on Kaggle, to understand what kind of things people have been creating on Kaggle, like especially in 2021. That's all we are going to do, and for that we are going to leverage a Python library called BERTopic. If this is something that interests you, let's get started. Make sure that you give a thumbs up to the video and also subscribe to the channel, and then let your friends know about this channel. So thanks to this amazing library, this library is called BERTopic. This library has been created by Martin Grutenhust. So thanks to Martin for making this amazing library and also making it open source, and it has got a very good documentation. I cannot tell you how helpful this documentation is. Like, if you do not even watch this video, you should be able to get up and running very easily with the documentation that you have, this documentation for this library. And also there are a lot of starter notebooks, Collab notebook, Kaggle notebook. You should be able to fairly easily, simply get started with this library. So what is this library about? BERTopic is a topic modeling technique that leverages transformers, and also I think it talks about Hugging Face transformers, and also c-TF-IDF, class-based TF-IDF, which means you can have TF-IDF for certain classes if you have class-based data. So this is used to create dense clusters, and those clusters can help you understand, interpret those topics, while also keeping the important keywords in the topic description. It supports guided, semi-supervised, and dynamic topic modeling, and you can see a lot of examples for this thing. And what we are going to see in this video is very simple application, a very few lines of Python code of application, simple topic modeling using BERTopic. Also with BERTopic, you have different flavors. So the one that we are going to do is installed with sentence transformers. So we're going to use the embeddings from that, but you can install it with Flare, you can install it with Gensim, you can install it with Spacey if you want to use respective embeddings, like word embeddings. But here we are going to use sentence transformers. So it's quite simple to install the library, and once again, this is a notebook that I've already created before I made this video, and I'm not running this notebook while I'm showing you on this video, because it took a lot of time for me to install certain libraries, and also like while the topic modeling process was actually happening. So that's why I'm not showing. Like, you can actually see how long it took. So it basically took quickly, if I scroll down, you should be able to see, where is it? Yeah, it basically took 1300 seconds. I don't know how much is 1300 seconds in minutes. It's about 22 minutes. So it basically took me 22 minutes, and multiple times I went through a lot of iterations. So that's why I'm not running this while I'm showing in this video, but you should be able to easily fork this notebook or copy and edit this notebook and then get started with this library without any issue at all. So the only thing that you would find a little strange when we install this library on our Kaggle notebook is, instead of just simply doing pip install BERTopic, I've also done no build isolation, no binary. So this is to make sure there was a NumPy error. So that was happening either probably with HB dscan or like somewhere it was happening. HDB scan, sorry. So somewhere there was some version mismatch. So that's why I had to do this thing. But otherwise, if you find you don't have that version issue, you can just simply do pip install BERTopic, as with any Python library. So the first step is you install the library. It takes quite a bit of time. After you install the library, so then you from BERTopic import BERTopic. So you can see how the case changes. BERT in uppercase, OPIC in smaller case. Now you have imported the library. So you have the library BERTopic ready to use. You have the library imported, the most important class for you, which is BERTopic, available for you to use. The next step is we need to prepare our text data. And that text data that we are going to prepare does not simply exist as text. The reason is because we are trying to use Kaggle metadata. So if you have not heard about Meta Kaggle Dataset, let me quickly show you the dataset. Where is the dataset? Let me open it in a new tab. So Meta Kaggle Dataset is a very useful dataset. I found it very useful. It's a Kaggle dataset, public data that is available about the competitions, datasets, kernels, and notebooks that are available on Kaggle. So if you want to explore what people are discussing on Kaggle, you can use Meta Kaggle. If you want to understand how people are ranking on competitions on Kaggle, you can use competition dataset. If you want to understand what kind of datasets people upload, like where do grandmasters rank, do they give more upvotes or less upvotes, all these things you can leverage using Meta Kaggle. Meta Kaggle is a wonderful dataset. As the name suggests, it's Meta Kaggle. If you have not leveraged Meta Kaggle, I would strongly recommend you to check out Meta Kaggle. I've got a couple of Meta Kaggle notebooks. I can link it in the YouTube description for you to get started if you're interested in this area. So this is Meta Kaggle. Within Meta Kaggle, the file that we are going to use is called kernels. So this is kernels. Where is kernels? So this is the file or table, whatever you would like to call, what we are going to leverage for this particular project. So it has got the kernel. So kernel is that older name for notebook on Kaggle. So they recently renamed it to notebook, but it used to be called as kernel. So you have the kernel ID, you have the author who created the kernel, and you have got current kernel version because kernel can have multiple versions. And you have the forked parent kernel, which says whether it was forked, if it is related to forum topic, and so on. So the most important thing that we are interested in is, which is, let me deselect everything, and then I'm going to say current URL slug. So this is the column that we are interested in. What is a current URL slug? So let me show you a Kaggle notebook. You can see my Kaggle notebook here. So this is the URL slug that you are talking about. So if you take my notebook, this current notebook that we are just creating as part of this video. So the slug contains Kaggle Notebooks 2021 topics model using BERT. And how is this slug decided? The slug is basically the HTML, like encoded version of the title that we give. So whatever title you give here, so the slug is basically this. Just, it has got dashes between, like there is no space because you cannot have URL with space. That's basically it is. So what we are going to do in this project is leverage this column name called current URL slug and then do topic modeling on top of it. So this is a very brief explanation about the data set that we are going to use. So we're going to use Meta Kaggle data. We are going to use the kernel data. And within kernel data, our topic or column of interest is current URL slug, which is a proxy for title, Kaggle notebooks title. Okay. So at this point, what we have done, we have successfully installed the library and we have learned about the data set that we are going to use. So next we are going to use two more libraries, pandas SPD for reading the input data set, the data set we just discussed, and datetime. We want to filter this data only for 2021, the year 2021. I mean, you can do it for all data. There is no harm in it. Like you can do a time series like dynamic modeling as well. But because I don't have a lot of time to, look at my screen for it to run a lot of time. So I'm just limiting this for 2021. And also this is more like a summary, like it's like Spotify Unwrapped for Kaggle notebooks. So you have 2021 data alone. So I'm using date time to filter that only for 2021. So the next thing that I'm doing here is pd.read_csv, copy the path of this, like you can just go here to the notebook section, like dataset, copy the path of the kernels.csv and then paste it here, and you have the kernels read. So your data set here, the data frame is read as Python object kernels, which is a data frame. So the table has got current URL slug, which is basically the proxy of a notebook title. So we are going to use this column for topic modeling. This is how the head is. We already saw about it. And we need to filter our data set, data frame for only 2021. So I'm just using creation date, the column creation date. You would have seen that column here. You have creation, yeah, you have got creation date. So this is the column name that we are going to use. As you can see, it is currently it is a string that is in timestamp format. So I'm converting that to date time, and then I'm comparing it with 2021 Jan 1st till 2021 31st December. So I'm basically filtering the data between, I mean, when you are going to see this video, it's not even going to be 31st December, but again, like that's a whole idea, right? We can even rerun this notebook after the year finishes as well. While we are doing this, we are going to do two things. What are we going to do? We are going to keep our kernels 21. So now this is our subset, right? So we have made a subset of kernels, which is only for 2021. So we have filtered by timestamp, keep only 2021 data notebooks. So what we are going to also do is we are going to make sure we have only the original notebook, not the forked notebook. So if you're new to Kaggle, fork is just simply copy and edit. So copy and edit is basically you can copy this notebook, fork this notebook and edit it on your own. But the point is the new notebook that you are editing could be as original as the original notebook. A lot of time people, for simplicity, like, added, for example, dataset could be there, or a library could be easy to use. So for that purpose, they might be forking a notebook, or sometimes people might simply copy an existing notebook. Like for example, if you see a lot of competitions, fork of fork, fork of fork, fork of fork. So there could be a lot of forks like that, and I don't want those kind of data to skew our results. So that's the whole point why we are excluding the forks. So we are keeping only the notebooks that are completely original, OG notebooks. So we are doing that by saying fork parent kernel version. If it is not null, we are excluding them, right? If it is null, what does it mean? It means this is the original notebook, so we are using not null, and then we are excluding that. And then also we are trying to say if total views are not even 1, I mean if total views are just 0, then we are excluding those kind of kernels as well. So this is again to bring slightly more sanity to the dataset. That's a whole point. There is no, not much more logic than why we are doing this thing, but the idea is reduce the size, keep only the OG notebook, and then exclude all the kernels that are not even like viewed one time at least. Okay, so after that we have got a huge dataset name. As you can see, it says kernel 2021 no fork GT 0 blah blah blah. So you have got a big data frame name. So we have got a data frame name. Ignore this shape, that's fine. So after we do this thing, what we have to do is now we need to give the input, right? So this is currently a pandas series. If you it's a pandas data frame. When you take only the column name, like current URL slug, so you are ultimately ending up a column pandas series. So I'm converting that into a list, just to get rid of all the index problems, all these kind of problems. So at this point we have a list, Python list object that says Kaggle notebook titles. That's a typo, sorry. Kaggle notebook titles 2021, and this has all these titles that are from the notebook from 2021 that has more than 0 views and that are parent original notebooks forever. Okay, so at this point our data preparation is done. So that's a good thing about this library. You don't have to do anything more than this for data preparation. You're not going to manually create embedding. You're not doing any of those things, unlike many other NLP libraries, especially when you deal with topic modeling. So your data preparation ends here. The next thing is you have to define the BERT topic. So now you have to say, do you want verbose? Okay, cool. Yes. What is the embedding model that you want to use? So this is now a very important question for you to understand. Now, for us to understand this, I'm going to go back to the documentation and show you embedding models. Let me zoom in a little bit and show you that by default, it uses sentence transformers. And you can select any model from sentence transformers here. So the default version of the BERTopic that we installed, it uses sentence transformers, and within sentence transformers, all these models are hosted on Hugging Face Model Hub. And then you can see what are the benefits of these models. Like for example, what is the size of the model? What is the performance of the model? Like speed. So you can pick a model that stands fine for your use case. Do you want speed? Do you want higher accuracy? So you can make that call. So select a model here. I think the model that we have selected here is all mini L6. Yep. No, paraphrase mini LM. So if I go here, paraphrase mini LM. So this is the model that we have selected. It's small in size. Speed encoding speed, higher is better. So you can see it has higher speed. So we have selected a model that is small in size and faster, but again, you know, that comes with some kind of limitation. So based on your use case, whether you're doing a hobby project or you're doing something for your organization, something serious, you can select the embedding model. So this embedding model is basically based on the transformers library that you have selected. For example, right now, like I said, we have used sentence transformers, but let's say you're going to use Spacey, you're going to use Gensim. In those cases, you will have a totally different kind of model used. Like for example, Spacey, it will be like this. Let's say you're going to use Flare, so you're going to use something like this. So it depends upon what you are using, but the author has pointed out that sentence transformers works amazing out of the box. So you can definitely try different models within sentence transformers if you want to improve your result. So the next thing is, what is the minimum topic size? You want 50, and then calculate probabilities. So calculating probability is another important area. So what is the use of calculating probability? Once you calculate probability, let me quickly show you topic visualization. And if I have to show you probability, once you calculate probabilities, these probabilities can be used to gain confidence about the topics that we have created. So if you do not do this, like for example, at this step, if you by default calculate probabilities is false. So at this step, if you do not do calculate probabilities, you wouldn't be able to leverage the probabilities that come with this thing. So if you want probabilities, make sure calculate probabilities is true. So especially in an organizational context, this is quite important if you want to gain confidence from your stakeholder about what you are building. So at this point, we have created an instance topic model. Okay, very typical like your scikit-learn or any machine learning library that you use in your Python ecosystem. So now after you have created this object, now you're going to say topic model fit transform, and then the list of string, which is the titles that we created, and then you give it. It's going to download the model, and it's going to slowly start the process of topic modeling, which is it's going to say, okay, transform document into embeddings, and it's going to say reduced dimensionality with UMAP, and then it says clustered UMAP embeddings with HDBS scan. Okay, so this is again a density based clustering method. So basically three things happen here. First, the documents are encoded into embeddings, and then it's reduced, the dimensions are reduced with UMAP, which is very similar technique like your TSNE, I mean in the same world, like dimensional reduction technique. And finally clustered UMAP embeddings with a clustering method, HDB scan. So after this, you're done. Your topic model can be used to get topic info. So now you can take the frequency and then see the top 5 topics. So these are like, you know, topics. So as you can see, the first one, like the -1 is like the most meaningless topic. So it's mostly like junk. You can completely ignore that. But in our case, you can actually see that even then you have like certain topics that do not make much sense. These are mostly like, I think people have created notebooks, but they've not they've not given a meaningful name. So what happens on Kaggle when you create a new notebook is it starts with a notebook, and then it gives you some random number for your notebook. So this is basically mostly people who, like, you can see the count as well, right? So this is mostly people who have created a notebook, but they didn't give a meaningful name to the notebook. And then some notebooks where people put their actual name, like their own name in the notebook. So one is like set where they didn't name anything meaningful. The other is like a set where they've given their name, and then you can start seeing like rest of the topics being useful. And when you see like if you see the first one, like you can actually see, right, notebook. So basically you get an idea, like for every topic you can actually select like 0, 1, 2, 3, you can select and then see what kind of keywords are there in that particular section. So the most important thing and interesting thing that I found out of this is the interactive topic modeling, which is basically what LDA Viz would do. If you have done LDA before, which is a very popular topic modeling technique, so this is this is how you would see something. So this is basically a map or a chart that gives you intertopic distance. So this helps you understand how these topics are there. Like for example, you can basically go, you can like select a topic, and then you can select a topic and then see what is the topic. For example, I can go topic 2. Okay, topic 2, these kind of keywords. So I have topic number 29 that has words related to loans, lending, club, default. So you can understand. So there are like notebooks created in this topic which is related to loans, default. So for me, this is very important, because now if you are somebody who is trying to understand Kaggle notebooks created, or a data scientist interest of BFSI in lending, so now this gives me an idea about that sector. So now this is all related to, you can see there is a topic number 46, it talks about basic Python list introduction, and there is a topic number 215 that talks about visualization. Now there is a topic number 243 that talks about only hackathon. It has by mistake put Hacker News probably somewhere there, but you can see the idea. You have topic number 217 which talks about forecasting, time series forecasting, FB Profit, which is again a very popular forecasting library. Somewhere I saw an AutoML as well. So you have topic number 18 that talks about facial recognition, OpenCV. Let me see if AutoML is there somewhere. Twitter, all assignments. Now if you want to extract all the notebooks that are assignments somebody had created, you can actually find out that. I'm still looking for my notebook that talked about AutoML. So if I cannot find, I think that's completely fine. You have topic number 26, Light, GBM, XGBoost, Optuna. Okay, I think I couldn't find. That's okay. That was interesting, because in that topic you can actually see how it had grouped the libraries that are used for AutoML. It's a shame that I couldn't find it now. That shows that I should have noted down the topic name when I was checking. Okay, that's fine. Yeah, so basically this works really fine in my opinion. I mean, like we didn't do any text cleaning, we didn't exclude, like for example, what we could have done is we could have excluded these kind of notebooks, right? Notebooks that do not have any meaningful name, notebook that just starts with notebook that has numbers like hexadecimal numbers. So we could have done all these things. We didn't do any of those things. Still, like we have exited with really good interesting topics. And then we can also see how these kind of, like what kind of topics people have put under those things. Like, so this is really extremely useful. But if you want something beyond this thing, then again you have a lot of other visualization options. For example, one of the most popular visualization option in topic modeling is visualizing the topics in terms of a bar chart. So if you have ever done TF-IDF, you would probably see like this is how you would like to represent your TF-IDF. So there is a topic that these are the keywords related to that. There's a topic, these are the keywords related to that. There's a topic, these are the keywords, and you can increase like the number of topics that you want to see. And it doesn't end here, so I've stopped there, but you can see what other visualization options you have. You have a lot other visualization options. Like one is the topic that we saw, the other one is like you can try to group the topics. Now you can use clustering, hierarchical clustering, and try to group the topics and find out how much topics are similar, what two topics are similar, like this topic and that topic, which are those topics that are similar. So you can do a lot more things, and in fact you can even use the elbow method to identify what is the ideal number of keywords or number of words in a particular topic. Like if you see this chart, you can see that there is a strong fall after 3. So you can say, okay, maybe 3 is probably like my right answer. So you can make that call. So this is again an important thing. And you also can see visualize topics over time. And this is something that I wish to do on this particular data set as well. Can I track the popularity of topic over a period of time? Because I know like on Kaggle, If you see 3-4 years back, everything was XGBoost, and now everything is deep learning. So can we visually represent that, like change of topic representation, global topic representation? That would be really an interesting visualization for us to see. But again, because this current notebook is only about 2021, so like I didn't mind much. Then you can again do topics per class. Like if you have classes, like you can do topics per class. So you have a lot more things that you can do. You can even search for topics. You can say, okay, give me topics related to this, and then you can get all the topics. So you have like a lot more potential to do. All you have to do is copy my notebook, copy and edit this, and then start adding those from the documentation, for example, the new ones from the documentation, and you're like good to go. So this is basically what we set out to do. Use Kaggle kernel dataset, Kaggle notebook dataset, understand what kind of topics people have created notebooks about, and we have used BERTopic for that, and it's a wonderful library. I really thank, again, like I should definitely thank Martin for making this amazing library, making it open source and making it easy for anybody to get started. If you have any thoughts, let me know in the comment section. Otherwise, just go ahead, LinkedIn, Twitter, wherever you are, give a shout out to Martin for making this amazing library. And also, if you have any comments, let me know in the comment section. Otherwise, I hope you stay safe. Happy coding.